Hello, ladies and gentlemen. Today we're going to be talking about the property of density. So your learning objective related to this topic is that you can calculate the density of a substance and recognize that it is an identifiable physical property. So if we were doing some kind of identification of an unknown substance, density is a unique characteristic that can help figure out what that substance might be. So when we take a look at what density is, it's a ratio of the mass of a substance to the volume of a substance at a given temperature. It's a fancy way of saying how much stuff there is in a given space. Remember that when we talked about matter, we said those are the two measurements that we can have to call it matter. It has mass and it takes up space. Common units we would use because of that ratio: for solids we often use grams per centimeter cubed, for liquids grams per milliliter, and for gases grams per liter. Gases have very low density, so we tend to use very large volume measurements for that part. Density is a defining property for a substance, so even if I have different size pieces of the same substance, they will have the same density. So I can have a gigantic brick of gold or a tiny little speck of gold, but they will both come out to have the same density. Now the mathematical equation for density is that density is equal to the mass divided by the volume, or mass over volume if you want to think of it as a fraction. One of the things we'll have you do is you will have to know two of the values to calculate an unknown of the third. Now, if you want to get kind of a visual of what density represents, I'd like you to consider for a moment if we had people in a room. So if the room is made of tiles on the floor, and the tiles are all, say, 1 foot by 1 foot, we could use that as a measurement of the space. So let's say I had a group where there were 2 people in the room. In the space that we have here, they got a lot of open space around them. They're pretty comfortable. They're not packed in very tight. That's a fairly low density. There's a lot of space around them. But let's say I had a room where I had 8 people in the room, but it was still the same size room. Now they're going to be a lot tighter in that space. They're not going to have as much space around them. So this would be a much higher density. So visually speaking, when we say low density, we mean there's a lot of space around the particles. If it's high density, those particles are really tightly packed together. So one of the things I'd like you to do is draw a diagram in your notes of the results of this, just to give yourself kind of a picture diagram to reference when we talk about that. And for each, go ahead and label low density and high density. Now, if we were to apply that to some practice problems, the first thing we would always do is look to see what variables are in the problem. Remember that our density equation is density is equal to mass over volume. So I want to look in my problem and see, are any of those variables there? So right here we see 18.9 grams. Grams is a measurement of mass. I can label that the mass. Here we're told we have a volume of 1.12 milliliters. That's my volume. And we have to solve for density. So a gold-colored ring has a mass of 18.9 grams and a volume of 1.12 milliliters. Is the ring pure gold? We're given the real density of gold, so what we have to do is solve for the density from the problem and compare it to the given. So here we'll take our 18.9 grams, forgive me, I'm using the mouse, over 1.12 milliliters. Now when you punch this in your calculator, you're going to get the number 16.875. Now, we haven't talked a lot about this yet. We're going to learn a rule for rounding to the correct number of digits, but I will do our rounding for us today. I would report this answer at 16.9 grams per milliliter. Notice that there isn't anything we can cancel out in the units, so when we look at this part here, we have to include both units in our answer. So this makes sure that we're reflecting that it is a mass per an amount of volume. Now in this case, density is what we were solving for, so I'm going to put a box around that. I would like you to make sure that you are annotating each practice problem that you do in this way. This will be very consistent throughout the year. So given values, underline and label, box what you're solving for. Now you'll notice we still have to answer the question. We would say, no, this ring is not pure gold because the densities do not match up. We learned that density is a property that is the same for all samples of that material, and since it is not equal to 19.3, this must not be gold. Please make sure that as you continue to work through the notes, you finish the practice problems on the rest of the page, and an answer key will be available to check during class.